Hi, Assalamualaikum. My name is Nabila binti Muhammad Tajuddin from class DKA 3D. Today I would like to present about hydrodynamics, which is the concept of fluid flow due to presence of shear stress. We're going through the compressible and incompressible. So first, we need to know what is hydrodynamics. According to Wikipedia, hydrodynamics is a branch of physics that deals with the motion of fluid and the force acting on solid bodies immersed in fluid and in motion relative to them. Okay, we're moving on to the what is compressible. Compressible means it's a capable of being compressed, and incompressible is not able to be compressed. Okay, we're moving on to the difference between compressible and incompressible. So for compressible fluid is matter that can be compressed with the application of an external pressure, while incompressible fluid is matter that cannot be compressed even there is an application of an external pressure. For the compressible fluid, volume can be reduced with the application of a pressure, but for the incompressible, the volume cannot be reduced even when you apply the pressure. Next, for the density, the compressible density can be changed, but the incompressible density cannot be changed and remain same. Okay, we're moving on to the differences of the Mach number. Actually, Mach number is a degree of compressibility of a gas, so that we call as a Mach number. And the symbol is M, stand for the flow. For the compressible, the value of Mach number should be greater than 0.3, and incompressible, the value of Mach number is less than 0.3. So this is a picture, an example how it works. As you guys can see, for the compressible fluid, when pressure 1 is applied to the volume 1, the volume of V2 change. But you can look at the incompressible. When pressure 1 is applied, the volume 2 does not change and remain constant. Okay, compression and expansion are important characteristics of a fluid. Remember that a fluid can be a liquid or a gas. If compression and expansion have a significant effect on the fluid density, the fluid is called a compressible fluid. Okay, so consider a simple example of a gas in a cylinder as shown in this figure. The cylinder is sealed so that the gas cannot enter or escape. The fluid volume changes as the piston moves. However, the mass of the system does not change because the gas is not allowed to enter or leave the cylinder. Therefore, the fluid density must change because of the change in volume. Okay. On the other hand, when compression and expansion does not significantly affect the fluid density, the fluid is called an incompressible fluid. The volume of an incompressible fluid does not change and its density is treated as a constant. So, consider a liquid in a cylinder. If the cylinder is sealed, the piston will stop moving once it contacts the liquid. As the piston retracts, an empty space is created above the liquid surface. The amount of space, or we call it as a volume, the liquid occupies does not change. Actually, the volume does change, but the change is very tiny. Since the amount of the liquid is almost unchanged, the fluid density is constant. Liquids are always considered to be incompressible fluid as density change caused by pressure and temperature are very small. While intuitively gases may always seem to be incompressible fluid if the gas is permitted to move, a gas can be treated as being incompressible if its change in density is small. Okay, so consider the cylinder filled with a gas as shown in this figure. Pods are added to the cylinder that permit gas to enter or leave the cylinder. As the piston pushes down, the gas flow out of the pod because of the volume of the cylinder decreases. The amount of mass of the gas also decreases proportionally, and the density of the gas in the cylinder is unchanged. When the piston retracts, the volume of the system increases. Gas enter through the pod and the density of the gas remain again essentially constant. So in this situation, the gas behave as an incompressible fluid. In a strict sense, a completely incompressible fluid does not exist. However, when the density changes due to pressure, the movement of the piston applies pressure to the fluid in the cylinder, or temperature is small. Approximating a fluid as an incompressible fluid can greatly simplify by the calculation using the Mach number. So, in conclusion, fluids are relatively incompressible, but volume reduction can be significant depending on pressure, temperature, type of fluid, and also the system design. So that's all from me. Thank you.